What base should we use for number 1? 5. Great. Okay. So over here, I'm going to say 125 is 5 to the third. And 25 is 5 squared. Okay. And then I'm going to take 125 and make that 5 to the third. And then I'm going to put the b minus 2 in parentheses because I'm going to end up distributing that 80 equals 5 squared. And then putting that 2b exponent on there. Okay. Cancel, cancel. And I got a whole number answer for one of those, which is really infrequent. Okay, now number 3. How do I undo a cubed? Cube root. Cube root of 19. Okay, now I was just going to leave it like that, except for that right about now is where my third period class started giggling a lot. Yeah, they were like, hee, hee, hee. And I was like, what's with the cube root of 19? And then they were like, no, it's 2.67. So then I had to show you guys because, now it's funny. So just to humor them, I put approximately 2.67. Whatever we can do here in the math department to make it more fun, I'm all for. But really, I would have just left it the cube root of 19 and walked away. Okay. Now, can you guys flip to the stamp sheet side, please, and thank you? So there's been a mishap. This was supposed to be number 8, not number 7. Can you guys all put a number 8 over that 7? It was supposed to be 7-8. 7-7 isn't even a homework problem. It's a classwork problem. A 7-8 is just like the 2 warm-ups we just did, one of each. So you'd much rather do number 8, trust me. I'm really sorry, I don't know what happened. I think my fingy slipped on the keyboard. That's what I'm going with. I don't know. I was temporarily insane, something. I'm not sure. Also, this really doesn't look like an 8 either. I tried to make it an 8, but then now it doesn't look like an 8. Then I tried to do this where I just like swooped it like that. Oh, hey, that's not that bad. That was my best attempt yet, for sure. Okay, anyway, so on the homework, if you guys could do 8, 11, 12, and 13 instead of 7, 11, 12, and 13, that would be great. Okay, now we're going to the notebook, so you can scooch this off to the side. Just a note, we are going to use a graphing calculator almost all periods, so if you do not have one of those out or on you, you should make sure to have one. And I'm going to use 2 colors today. So just a quick note, number one is a review problem from chapter 5. And the reason that they're doing a review problem is because you were supposed to have like a 3-week gap, because we didn't do chapter 6. So if we had done chapter 6, it would have been like a couple of weeks since we talked about logs. So they did this review problem. We're gonna do it anyway, because why not review? But if some of it sounds like, yeah, we just learned this, that's because we skipped chapter 6. Chapter 6 has more statistics stuff in it that you don't need to know this year. I already taught you everything that you need to know for AP statistics to get to go to that class. That would be putting numbers in one variable stats and making a histogram and box plot. And if you can do that, when you get to AP stats, I'll be very happy. But you don't need the stuff in chapter 6. So we figure, why not go slower on the stuff we do need, right? Okay. So the first thing that they do in chapter 7 is they remind you about the Guinan circle. Okay, however, this one is in y equals, so I'm gonna make my Guinan circle go in that direction, because usually I go around the answer, but the answer's over here, so I'm gonna Guinan circle that way. Okay, so if you make your little loop-de-loop, which is what Miss Rice calls it, I'm sure Miss Franco calls it like the proper term, probably not the Guinan circle, probably not the loop-de-loop. She probably calls it the right thing. But it's so in my head, it's Guinan circle. I don't know. Anyway, so if you guys follow this around, where would my exponential start? B to the y equals x. And that's b to the y equals x over here. Okay. All right, now, next thing. I have to remind you that we're going to put a couple of bullet points. Log x, plain log x is log base 10 x. Remember, if there's nothing there, you put a little 10 as your base. That's because we have 10 fingers. And regular log is the log button on the calculator. Which is right next to the 7, not the 6. It's only next to the 7. It's not by the 6 on the calculator, only the 7. By the 7 only, not the 6. If that helps. So if you could take your calculator now and find the 7, not the 6, only the 7, and find the log button. I'm not sure if you can find it here next to the, not the, just the, yeah, yeah. Oh, there it is. I had no idea. I have to do my best to make it fun because it's dry. This material's dry. Okay, so if you press that button, that would just be plain log, and the little baby 10 will not be showing on the calculator, but it will be operating in base 10. And then notice above that, above the log button is its inverse, 10 to the x. So you can do second that. And the log base 10 and the 10 cancel, and you end up with 1 because log base 10 and 10 to the undo each other. Okay, now go over to this guy. Log base b. To get to that, you hit the math button and scroll to log base. Now, if you don't have that on your calculator, as we've discussed, There's other ways around it, which I will definitely go over again if necessary, but for now, hit the math button, find log base. Oh, there's a piecewise? Never saw that before. This moment. Log base 5 of 25 is 2. Okay. Now for C, what we're going to do for C is we're going to draw some of the parts of our blue sheets right here. So we're going to remind ourselves about graphs of logs. So what I want you to do first is make a little dashed vertical asymptote. And label that x equals h. Okay, then make a dot one spot over from your asymptote. I don't care where, just one dot over somewhere. That'll be your locator point. And then bring your curve up along the asymptote, hit the locator point, and take off. So that's what a log graph looks like. There's the general equation. I'm not sure what happened with the K, but it's fine. This is a really good time for you to see that h plus 1 right there. Okay, so there's like a little baby summary of your blue sheet entry or logarithms. And remember, it was supposed to be 3 weeks between times of talking about this, so that's why we're doing it right now. Okay, and that's all old stuff. That was number 1. Now we're done with old stuff. Okay. Now go ahead and set up number 2. Okay, everybody. So this is what we're going to do in problems 2 and 3. We're going to see if these two things are equal to each other. We're going to see if log base 2 of x is the same thing as y equals log 2 to the x. And how we're going to do that is by graphing. So get your graphing calculator next to you. Turn it on and go to y equals, and I want to type this with you, so I'm going to clear everything out. Clear out all of the y equals and make sure none of your plots are on. And the first thing we're going to do is type this one. So hit the math button, which is the third button down over here. Scroll to log base. Log base 2 of x. Lachlan, you can type log x divided by log 2. Or you can use one of mine. Okay, now this guy, you're going to go down to y2. And this is regular log. So that's the button that's next to the 7, not next to the 6, next to the 7. Regular log. And then 2 to the, which is the exponent button, x. Okay, now, when you get them both typed in, hit zoom, which is the middle button on the top, and then the number 6. Zoom 6. And what you're looking for is to see if those are the same graph. Are they the same graph? Definitely not. Okay, one of them is a log, which you expect. One of them is a line. Does anybody have an intelligent reason why this one would be a line and not a log? Steven? Yep. So the logness and the exponentialness cancel each other out, and there is a line left over. Even though they're not the same base, the effect still cancels out. Okay. So you're going to take your two colors. If you were using two colors, I'm going to sketch this in my little graph here. It doesn't have to be perfect. Do remember that log goes all the way down. Okay, and lastly, after you get your sketch, come back up here to your equals and make sure that that says not equal, because those things are definitely not equal to each other. Okay, now we're going to prove that they're not equal algebraically. I'm going to take this one and I'm going to write it down over here, except I'm going to put the y on the other side. That's because I like to do my guidance circles to the right. I'm not a left-hand guidance circle liker. I'm a right-hand guidance circle liker. I don't know. I don't know why. I'm just used to doing them on the right. Okay. Okay, so I wrote both of these down again, just with the y on the other side. Okay, and now I'm going to do guidance circle for both. And I will show you that they're not equal. So this one would be 2 to the y equals x. And this one would be what? What would I start with? Yes, 10 to the y equals 2 to the x. But those things are definitely not the same thing. Okay, and you're like, why do I care, Mrs. Talbot? What did I just do? Like, what's the point? Okay, and the point is, I want to see if there's any way that I can solve for the exponent, like that problem number 4 on the warm-ups tomorrow. So what I'm trying to do is figure out how to get the x to where I could get it alone. Okay, this is not the way, because this is a no. Okay, you guys good with number 2? Everybody good? Okay. Number 3. Okay, this is what I want you to do for number 3. You're gonna do this one in your groups together. Okay, what you're going to do is you're gonna take the left side and put it in Y1. You're gonna take the right side and put it in Y2, and then you're gonna hit the graph button and see if they're the same graph. You don't need to sketch the graph, you just put yes or no. These are just yes or no answers. Do you guys understand? Okay. You're gonna graph both separately, the left and the right, then hit the graph button and see if it comes up with the same thing. No. Some of the groups are splitting up the work. Right. I really like the one from D. It looks like a bird in flight.
I got 29. I'm sure great.
The bird in flight.
The B I ended up in.
That's exactly the same, like, you know, over the top of it.
Oh, you skip C. Yes, C, but he's the same.
He's the best looking one.
Yeah, but C the same.
Yeah, you see it, see it. Oh, I got that.
Yeah, that's what I got. Solve such a pretty easily. Yeah, we get a lot of quick.
Yeah, I know. Yeah.
I mean, I just read a
Yeah.
lot.
How are we doing?
He's right.
Oh, no,
They.
no, yes.
Okay, maybe they found it in the same, maybe they left.
Very socializing.
Well.
All right, guys.
You.
Great job. I think I saw everyone was correct. It's no. No. Yes. No. No, no, yes, no. Okay, and this one is very special. It's called the power property of logarithms. Okay, which is what I'm going to teach you next, which is how we can solve number 4 from the warm-ups tomorrow. Okay, the power property of logarithms is very special because what it does is it allows us, instead of solving for an exponent, to solve for a leading coefficient. Let me say that again. The power property is very special because instead of solving for an exponent, it allows us to solve for a leading coefficient. And we all know how to solve for a leading coefficient. You just divide. Okay, so this is going to look a little strange at first, but just trust me. So log base b of m to the n. And I want you to think about this one up here in C. So just pretend the little 10 is there. So that would be like log base 10 of 7 to the x. Okay, and then I want you to take your other color. If you're using another color, and bring that exponent in front. And if you bring that exponent in front, now it's a multiplication problem, and you can divide to get log by itself. Okay, so there's for my formula people. There's for my words people. The exponent goes in the front and becomes multiplication. Okay, now the last two problems are identical. You think I'm going to lose my mind, but no, I'm not. Not for this, maybe something else, but not for this. So what I want to do is for this first one, number 5, I want to guess and check on the calculator. So grab your calculator. And I want you to do 1.04 to the stuff until you can get as close as you can possibly get without driving yourself crazy to 2. So for example, 1.04 to the 1. Well, that's too low. 1.04 to the 2. That's still too low. 1.04 to the 12. Still too low. Okay, keep going on your own. Ooh, 20 is too high. It's not, but close.
Basic.
I think that's pretty good.
17.
It's not 6.7. It's not 6.7. It's not closer. Is it closer?
It is.
Okay, wait.
It's 17.
Okay. What I want you guys to do over here is just write x is about 17.675. By guess and check. Okay. Now we're going to solve it without guess and check. Okay. Oh no, kids. The cat is stuck in the tree. How do I get the cat down? I hit the tree with a log on both sides. Okay. Oh no. The X is stuck up in the tree. How do I get it down? I hit it with a log on both sides. Wham, wham. Okay. Now, take a look at this. I have this right here. I can use the power property of logarithms to bring the X in front. X times log 1.04. I can't write it though. I can say it, but I can't write it. Oh, look, now it's just a multiplication problem. To get X by itself, I just divide both sides by log 1.04. Oh, let me get it. Hold on. Log 2 divided by log 1.04. Is it 17.67298,679? 67298,769.
76.
Okay. This is how you can solve them without guess and check. So when the X is stuck in the tree, hit it with a log on both sides. Then the exponent falls in front and divide. Okay, now for log problems, I will almost always round to 4 decimal places called the 10,000th place. So I would call this X equals 17.6730. Now I do have a piece of advice. Do you guys know who Nate Bargatze is? Anybody know who Nate Bargatze is? He's a comedian and he has this bit about one fell swoop. And he says that his wife doesn't know what the word one fell swoop means.
Yeah, I'm gonna teach you what the words one fell swoop mean, and then you should go listen to his bit about his wife and one fell swoop, because it's really funny, but anyway. What I mean is, you should type this in all at once on the calculator. Type it in one fell swoop. Don't type log 2 and then round the decimal, and then type log 1.04 and round the decimal, and then divide them and round the decimal, because you're gonna get a rounded decimal off of 2 rounded decimals, and your answer will be really different from my answer. You just type it in. You just type it in. One fell swoop. All at once. So it's rounded 1 time and not 3 times. You really should listen to it. It's very fun. It's okay. Since you're all sleeping, I'll tell you. So this guy, his neighbor Godly, this comedian, he said that his wife was saying the word one fell swoop. And she's like, her parents are divorced. Her parents are divorced. And she wanted to go visit both of them. But she said she wanted to do it in one fell swoop. And he's like, okay, we'll do it in one fell swoop. And then she's like, yeah, I really want to do it in one fell swoop. And he's like, fine, we'll do it in one fell swoop. And then she said, I want to go visit my dad and then come home and then go visit my mom. And he's like, I don't think that you know what the words one fell swoop mean. And then they got in a huge argument about it. And apparently, like, the next day, he even brought it back up. And then he was like, you shouldn't do that with your wife because she'll be really, really mad. You should just, let her have the one fell swoop argument, except for that she didn't really know what one fell swoop was. Now you all know what one fell swoop is.
Enrique,
Enrique doesn't know what one
I
fell
think,
swoop
I
is.
think you have to tell him. What's one fell swoop?
I just meant when you type it in the calculator, type it all at once. Like, don't type it in little pieces. Type it in one fell swoop. One fell swoop.
Where did you find him?
Well, if you hadn't gone to the bathroom,
Yeah.
per chance,
Yeah.
that would have been evident.